So in this video today, we're going to be talking about how to solve equations that have variables on both sides. So if we take a look at our example 1 here, our equation is 2 plus 5k equals 3k minus 6. So I have variables on both sides of my equal sign. I have 5k over here and I have 3k over here. So when we see variables on both sides, we need to make sure that we follow the correct steps to solve. The very first step that we are going to do is we always are going to keep the variable, on the left. Okay, always keep the variable on the left. You can solve other ways as well, but in this case, we're always going to keep it on the left. That way that when we're solving it in class, everybody's on the same page. So if I want to make sure that I keep my variable terms, so k, on the left side only, that means that the 3k that's here, I need to get rid of that. I need to do the opposite operation in order to get rid of it. So in this case, I would subtract 3k on both sides. So under here, I'm going to write add or subtract on both sides to get rid of our variable. So the reason why I subtracted was because this is positive, and 3k, positive 3k minus 3k is 0. This will cancel out so that we're just left with a negative 6 on this side. Next, I want to make sure that my like terms are added together. So in this case, 5k and minus 3k are like terms. They both have the same variable. That means that I want to do 5 minus 3, which is going to give us 2, and I keep the variable here because we want to make sure that we keep that throughout. So 5k minus 3k will give us 2k. Next, I just want to make sure that this number here that was originally here just stays the same. We don't combine that with anything because this is a number, this is a variable, so we can't add those together. Next, when we're solving, we just want to get our variable by itself. So we're always going to add or subtract our number first, our constant, on both sides. So our constant here is 2. So we want to subtract this because it was a positive 2. So I'm going to subtract it on both sides, cancel it out, and I'm just left with 2k equals, and I solve on this side here. So negative 6 minus 2, that should give us negative 8. And our very last step here is we want to get rid of this coefficient that's in front, this 2 that's in front of the k. So we are going to multiply or divide to solve, to isolate our variable. In this case, I have 2 being multiplied times k. So that means that in order to get rid of this 2, I would just divide positive 2 on both sides. That would cancel it out, and I'm just left with k by itself. And I solve negative 8 divided by 2. Negative 8 divided by 2 is going to give us negative 4. So my final answer would be k equals negative 4. Make sure that you also double check your answers here, so I can double check that negative 4 is my correct answer. All I need to do is go back to the original equation and plug it in. So I'm going to rewrite the original equation down here for my checking the answer. So my original equation was 2 plus 5k equals 3k minus 6. So I'm going to plug in that negative 4 that I got for my variable. So plug in negative 4 for k, and plug in negative 4 again because it shows up again. And I'm just going to solve with my order of operations. So multiply first. 5 times negative 4 is negative 20. And 3 times negative 4 is negative 12. I keep these in parentheses so that I don't get my negatives mixed up. And then I just solve, so 2 plus negative 20 is negative 18. And negative 12 minus 6 is also negative 18. So because it is equal, the same number on both sides, that means that I did it correctly. You always want to make sure that when you check your answer, you have the same number on both sides, so that we know that this is the correct solution. Alright, let's look at a different problem. Very similar way to solve. In this case, we have parentheses and then a number on the outside. So what we're going to do here is we're actually going to start by distributing. Normally, whenever you see these parentheses, you can just distribute right away. So we can distribute the 3. So that means I'm going to multiply 3 times 6 to get 18, and 3 times negative 2a, which is negative 6a, or minus 6a. So our first step here was that we distributed the number on the outside. On this side, nothing changes. It's still 8a minus 10. Then we solve like we did for the first example. We want to get rid of this variable here. Because this is a negative 6a, I'm going to add 6a to both sides, because that will cancel it out. So I only have variables on the left. When I add 8a plus 6a, I get 14a minus 10 equals 18. And then next I just solve with the constants first, so plus 10 to both sides. I get 18 plus 10, which is 28. I brought the 14a down from here. And then we divide 14 on both sides, so that we get a by itself. So 28 divided by 14 is positive 2. So for this example, our answer is positive 2. And then we can also go in, check our solution by plugging it back in. So I'm going to check my answer here. Our original equation was 8a minus 10 equals 3 parentheses 6 minus 2a. So I'm going to plug in positive 2 for my variable. And I can just follow order of operations again to solve. So I will multiply on this side. So 8 times 2 is 16. On this side I have parentheses, so I want to do inside the parentheses first. So inside the parentheses I have 2 times 2, which gives us 4. And 6 minus 4, which gives us 2. And then I can just finish solving here. 16 minus 10 is positive 6. 3 times 2 is also positive 6. So this, I've just confirmed, is my correct solution.